Assalamualaikum warahmatullahi wabarakatuh. In this video, we will talk about the system interrupt in multi-core architecture. We choose Apple M2 to explain more detail about the system interrupt. Before we start with our introduction, let me introduce our team member. First is Muhammad Alif and Muhammad Nakif Danish, and me is Muhammad Amir Haikal. Starting with the first session, the introduction to our presentation. I will explain three main things in this part, which is the definition, importance, and the overview of the M2 processor. Okay, first is the definition of an interrupt. An interrupt is like a phone call to the processor when it's busy doing something, but an important signal tells it to pause. It quickly deals with something more important, and then it goes back to what it was doing before. So the processor remembers exactly where it left off, so nothing is lost. Next is the importance of interrupt in multi-core architecture. Number one is improved system responsiveness. This means it has a faster reaction, so the system can quickly respond to a new task. Number two is better load distribution. The task can be divided among cores to avoid overloading one core. Three is parallel processing. It can handle multiple tasks at once. Next is interrupt affinity and scalability. 5 is the efficient of input and output handling, so it responds smoothly to devices like keyboard and mouse. 6 is it supports real-time and critical application. Overview to the M2 processor. So it is the second generation of Apple Silicon chip. It built on second generation 5nm process technology. So it was introduced in June 2022 as successor to M1 chip. So M2 processor feature 8-core CPU with 4 high-performance cores and 4 high-efficiency cores. It also features 10-core GPU and it supports up to 24 GB of unified memory. So the M2 processor also have 16-core neural engine.
I would be continuing explaining about organization in Apple M2 chip architecture. There is 5 main parts in organization of Apple M2 chips. That is the first part, Apple M2 chip multi-core architecture. Second, interrupt handling flow in macOS. Third, type of interrupts in M2 chip. Fourth, role of interrupt controller in M2 chip. And the last one is example in real system. How Apple M2 chips handle interrupts. There's two types of interrupts, that is global interrupts and local interrupts. Global interrupts come from shared device or peripherals in SoC, system on chip. They are not bound to a single CPU core and can be handled by any core. Type of global interrupt is SPI, shared peripheral interrupts. For the second type of interrupt, that is local interrupts. Local interrupts are only visible and handled by one specific CPU core. They do not travel across cores and do not involve centralized interrupt distribution. Two main types of local interrupt is PPI, private peripheral interrupts, and SGI, software generated interrupts. This is the interrupt handling flow in macOS. Type of interrupt in M2 chips. First, hardware interrupts. Hardware interrupt being generated by hardware component within the system. For example, timer interrupt, I/O interrupt, PCI interrupt, interprocessor interrupts, performance monitoring interrupts. Second, software interrupts. These interrupts are triggered by software to invoke specific kernel routines and communication between processors. And the third, exception. Exceptions are events that cause a break in the normal flow of program execution. For example, page faults, system calls, and illegal instruction.
Hello everyone, today I will share about crucial component in modern system on chip, which is role of interrupt controller in Apple M2. Generic interrupt controller, or in short GIC, are used by Apple M2 chip as interrupt controller. As we know, the chip is based on ARM64 architecture, and a key part of the architecture include ARM GIC. So, what does the GIC do? It has two primary functions, which is, firstly, it receives, manages, and routes the interrupt from various sources. These sources can be external hardware device like USB driver or external software events. And secondly, it delivers this interrupt into appropriate CPU cores. This ensures that important events are addressed quickly. To perform this function, the GIC is structured with several key components. The distributor is the central point that receives all incoming interrupt requests. It's responsible to deciding which CPU core should be handled them. And number 2, the CPU interface. This component acts as a bridge between GIC and CPU cores. It allows CPU core to manage pending interrupt that the distributor assign. And number 3 is GIC distributor. This component helps interrupt delivery across multiple cores. To make this more concrete, let's walk through real-world example how an interrupt handled in M2 chip. First, imagine that you plug in USB device to your MacBook Pro 2002 that use Apple M2 chip. This interrupt signal received by GIC distributor and quickly determine which core are suitable to handle this USB event. Next, GIC routes the interrupt to CPU cores. Let's say it routes it to core 2, and lastly, core 2 will pause the current program and immediately handle the USB device events. Once the execution done, core 2 will resume its pause program. Now, let's look at a common real-world example how interrupt works in Apple M2 chip, specifically when you move your USB mouse. It starts when the USB controller detects any movement from your mouse. This physical action will be translated into something that a computer can understand. After detection, the USB controller immediately issues an SPI or Share Peripheral Interrupt. This SPI directly goes to GIC distributor. The distributor job is to receive and quickly determine which CPU cores are suitable to handle this mouse event. Once a core is selected, chosen CPU will pause its current task and immediately read the USB data and interpreting it as a mouse movement. And finally, based on the interpreted data, the system updates the cursor on your screen, giving you real-time feedback of your mouse movement. To summarize our discussion today, in conclusion, interrupts are truly a key part of how the Apple M2 chip in the MacBook Pro manage its tasks efficiently and keep the system responsive. By leveraging both local and global interrupt, the M2 chip's multiple cores can effectively handle different jobs at the same time, ensuring smooth performance even when many happening at once. The interrupted controller, the GIC, we talk about along with Mac OS, work hand in hand. They manage and distribute this interrupt fairly and quickly, which is crucial for preventing system overload and maintaining stability. Ultimately, proper interrupt management is absolutely essential for enabling multitasking, achieving fast response time, and ensuring reliable performance in a modern multi-core processors like Apple M2.